Bismillahirrahmanirrahim. Alhamdulillahirrahmanirrahim. Wassalatu wassalamu ala anbiya'i mursalin wa ala alihi wa sahbihi. Rabbi sadri wa yassir amri wa hlul 'uqdatam min lisani yafqahu qawli. Assalamualaikum warahmatullahi wabarakatuh. Welcome back, guys. Today I will share with you the engineering design chapter 10. Today topic about the failure method analysis, effect analysis, FMEA. You call it FMEA. Second one is trade-off in certification, robust design, failure method, effect analysis, and summary, and a little bit about the design tolerance. Okay, why we wonder about the product performance? Okay, why we want to the product perform as expected? How it can be last long? Is it to be maintained? Okay, this is some question you can think about the prediction performance. Okay, then no damage occur to product, no damage to or harm to environment, no harm or injury to the operator or user. These are method to ensure performance. Okay, design for awareness. First, method to reduce the sensitivity of product performance to variance such as manufacturing, meaning material and process, where operating environment. Currently we use the Taguchi method, probability optimal design, both method using the statistic and theory, probability theory. Okay, what is FMEA? FMEA is a method to systematically identify and correct potential product or process deficiency before they occur. Okay, meanings first, to eliminate the cause of the potential failure mode and to reduce the severity of the failure. Example, what can go wrong with hydraulic lock splitter? Hydraulic hose on the home use lock splitter began to leak. The leak reduced the pressure to the piston ram, resulting in poor splitting. The leak drip oil on ground, creating a mess. Costly too. Upon examination, a weak spot is found a house due to poor manufacturing. Okay, the defect in design or manufacturing might cause the part to fail to perform. Okay, another example, you can fail elastic of deformation causing interference, plastic deformation due to bend or dent, ductile marring, ductile failure, brittle failure, fatigue failure, corrosion, weight, noise, leaking, scoring impact, blocking, open circuit, short circuit. Okay, metal degradation, oxidation, terminal explosion, and many more. So the concept of FMEA, failure mode, the way a part fails to perform. Example, hose leak. Okay, effect, adverse consequence of fail mode. Hose leak, result of oil spill, refill cost. Effect can be the severe or hardly noticeable. Cause: when it fail or may fail, poor host manufacturing, improper press cause occur with some likelihood or probability. Detectability: the ability to discover the cause before the part is shipped from the factory. Okay. How? We conduct the press test to detect leak. Okay, measuring the risk of the failure mode. First, determine the rating for each mode of failure using the risk priority number. We call it RPN. RPN equal to severity rating times occurrence rating times detection rating, meaning S times O times D. Okay, RPN will range 1 to 1000. Higher RPN is bad, means not good. Okay, and low RPN is good. How do we determine the RPN? First step, determine the failure mode. We can get from the engine design specification, function decomposition diagram, function from the meter energy signal, also from HOQ, from the free body diagram, force flow diagram, process flow diagram, configuration sketch or drawing. Step 2, determine potential effect of each failure mode. Okay, meanings, okay, example, you have product. Before you start the production, you need to do the FMEA. Okay, you are thinking, brainstorming what the potential effect, potential failure of the product. Determination of severity rating for each effect from the severity rating table. Step number 4, determine an occurrence rating for each cause from the occurrence rating table. Fifth step, determine a detection rating for each cause from the detection rating table. Okay, this is example. Severity rating number 10 to number 1. Okay, meaning number 10 is the catastrophic level. It's a discussion like a cause injury to people, property and the environment. Number 9, number 10 not only injury, can be some the death also as a number 10. Number 9, extremely harmful, cause damage to product, property and environment. Number 8, very harmful, cause damage to product. Number 7, harmful, major degradation of function. Number 6, moderate, cause partial malfunction of product. Number 5, significant, perform loss, cause customer complaint. Number 4, annoying, loss of function or annoying, cannot be overcome. Number 3, minor, some loss of perform but can be overcome. Number 2, insignificant, very little function degradation. Number 1, no noticeable effect in function or harm to others. Occurrence rating table. Okay, so number 10 to number 1. Number 10 is meaning expected, more than 30% occur the problem, meaning 1 per day. Number 9 is very likely, 30% of 3 per part, per 10 part. Number 8, probable 5%, 5 per 100 part. Number 7, occasionally 1%, 1 per 100. Okay, or once per month. 6, more possible 0.3%, meaning 3 per 1000 part, 1 per 3 months. 5 possible, okay, between the range. For remote 0.06, 6 per 10,000. Number 3 unlikely, 0.00006%, 6 per million. Number 2 is unlikely, and number 1 is improbable, less than 2 per 1000, and now it's a billion. 5 years for failure. This is correct. Impossible, it is 10 highest. Okay, then when we get 490 is 7 times 7 times 10, we get 490, and then the recommendation is implement pressure test. Okay, next we design for safety. Make sure safety is talk about the injury, hazard, condition, circumstance, legal responsibilities, guideline for safety product, safety hierarchy, and safety design principle. What is a safety product or system? Make sure no injury to user, no injury to consumer, no injury to products of production worker, no damage to personal property, no damage to real property. Okay. Hazard definition. Hazard is a source of danger which has a potential to injure people or damage property or environment. Okay. Hazard include entrapment, contact, impact, injection, entanglement, noise and vibration. Condition, circumstance. Okay, hazard is inherent during the normal uses. Hazard originate from the component failure. Hazard caused by the user misuse. Hazard assembly during normal maintenance. Hazard created by improper maintenance. Hazard stem from lack of maintenance. Okay, this legal responsibility. Okay, productivity must consist the concern about the civil action and criminal action. Okay, plaintiff attorney will try to prove that company or employees fail to perform appropriate analysis, comply the publisher standard, to make use of a state-of-the-art technology due to ignorance, include maintenance safety feature or device, take into account how the users might misuse the product, consider hidden dangers that might surprise the user, consider variation in material manufacturing process, effect or wear, carry out appropriate testing, interpret result correctly. Okay, this is a guideline for safety product system. First, perform appropriate analysis, comply the published standard. Okay, this is same as a slide before. Okay, safety hierarchy method. First, eliminate the hazard. Okay. Second one, protect against the hazard. Number 3, warn against the hazard. Number 4, provide training. Number 5, product personal protection, meaning use the PPE. Okay. Safety design principle. Okay. Save life. First, entire predict useful life without malfunction. Okay, designers to identify all operation condition, misuse of abuse, design appropriate maintenance and repair schedule. Number 2, fail safe. Person fail of component, product and system, shut down safely. Critical function or sometimes still perform. Example, boiler, feeder water, bath filling into the open position. Redundant design. Additional product, component or system are designed to take over the principal function of the failure component of system. Example, multi-engine airplane emergency brake. Okay, summary for this slide about the FMEA. Mode of failure, severity of effect, cause of failure, detectability, and then RPN. Come on to task detect risk, to assess the risk, so that we design the manufacturing improvement can occur to prevent failure made or redundant severity. Okay, I will okay, some about the design for safety, hazard and exit depend on condition. We have a legal responsibility, more guideline for safety and product, safety hierarchy, maximize our design effort and safe design principle. Okay, I will talk about the little bit about the dimensioning and tolerance design. Okay, from the figure, you can see the dimension for this the part. We have dimension A, B, C, D, E, F. Okay, if we have dimension, size, allocate and orientate for each. Okay, tolerance. Tolerance. The very small tolerance become the heights cost for manufacture. Is what they find and commercial find and cost tolerance. When you give a tolerance to the more than plus minus 0.1 is normal. Okay, but when you set the tolerance, example 10 mm plus minus 0.001. Okay, this means 1 micro. Okay, the machine, capable machine, we need a more precision machine to create this part. Okay, this year I will teach you about the worst case scenario design. Two meanings, we have part A, part B, part C. Okay, we want to assembly part B and part C to inside the area to part A. Okay, make sure. Okay, here the you means part B, dimension B high B is have a tolerance plus minus. Also here, okay, here we have a tolerance here plus minus T A T B. Okay, this here also we have a plus minus, and then this also we have a plus minus. Okay, from this we want to get to gap. Okay, dimension gap. The formula is dimension A minus dimension B minus dimension C. Okay, A is 1 minus B minus C, then minus again plus minus tolerance A. We have tolerance A here. Yes, and then we have tolerance B here, tolerance B and tolerance C. Tolerance C here, here, and we get the okay nominal gap minus total of the tolerance. Okay, another method we can use the statistic tolerance design. The formula is below. Okay, I think this is all for today. Thank you for your attention. Okay, see you next time. Assalamualaikum warahmatullahi wabarakatuh.